So good morning, everyone. Thank you for attending today's colloquium presentation by Dr. Amiangshu Bosu, and we're glad to have him here today. Dr. Bosu is the assistant professor in the Department of Computer Science at Windsor University, very close to us. He's an expert in the area of the code review, promoting diversity, equity in software engine developers communities. He won the prestigious NSF Career Award in 2024, and he has been published in Doctor Research Conference and journals. So we are glad to have Dr. Amiangshu Bosu with us. And if you
Thank you. Thank you. Thank you for your introduction. You can all hear me, right? Okay. Thank you so much for inviting me. So before I start my conversation, it's how I met. Okay. So it's funny. We went to high school. We are in the same class, and that was in year 1998. So yeah, and now we are professor like halfway in the world is in Windsor and in Windsor State University. These two university campuses are like only 2 miles away. I guess 2 or 3 miles. Okay, so today I'll be talking about building diverse and inclusive software development community through healthy community. Okay, so my research area is software engineering, so I talk about software development, how to make software development better. And one of the key part of software development is not only technical, definitely, you need to have this technical skill and technical superiority, but it's a human problem. A large-scale software cannot be developed by one person. It's a communication and collaboration between diverse skills, and possibly some of the cases will be 10% or 100% or 1,000%. Now, you can be a star software developer, very good software developer, but if you cannot work as a part of a team, then you are not valuable, right? And a software developer is valuable only when he can work as a part of the team. Now, that's why a lot of my research focus on improving communication, collaboration, team building between software developers. Now, let me give you a brief introduction from the general area. And how many of you here use social media like Facebook, Twitter? Everyone? Okay. Do you like it? So we are using it again. So social media, we have kind of love-hate relationship with social media. A lot of things that are going on social media, we don't like it. But still, we cannot live without it. Okay? So one of the dark side of social media is going on is toxic communication. And people do not like each other. If they do not like something, they will post harsh critique. So cyberbullying. Then you have this trolling. And maybe if you are very active in social media, at some point you have been victim of cyberbullying or like trolling or hate speech. Right? Someone attacks your identity, someone attacks your gender, someone attacks your religion. These are very harmful. These have real world consequences. Now, to give you statistics, so a research by Pew Research, J.D. Supra, it said that 65% of the young persons, like 18 to 29-year-olds, have experienced online harassment. Okay, 28% Americans admit online trolling. 77% of Americans believe that anonymity fuels online trolling. You can post anonymously. Uh, People become more harsh. 27% of the internet users have been insulted. So roughly 4 in 10 Americans have experienced online harassment, and there are a lot of reasons. The politics and different kind of things is going on there. So online, we all agree that online harassment is horrible. Okay. Now, what is the impact of online harassment? So due to this online harassment, people are going on a lot of different ways. Many experts think that this will get even worse. And the social media companies, if they want to survive, they will use more like bots or automated mechanism, detection mechanism. And we already see that. You know that a lot of the time you post something on Facebook and Facebook says that remove that post automatically, flag that post. And you're surprised why folks remove that. Because their automated detection mechanism is not that good. Yeah. So, and there is like fake news, especially there is we are like on the 2 weeks from the election in the USA. This things is going on a lot. Now, the internet culture has become like very bad nowadays. So there is an insult, there is a like hate culture, and these things have real life repercussions. So, for example, toxic workplace cultures, if a company has a toxic workplace culture, employees are more likely to leave. And people get frustrated. There are a lot of people who have committed suicide due to this culture. And we all are aware of these issues. And even like if you think about software development arena, so any of you, any of you played online games, MMORPG, massive online games, just notice that these communities have very kind of trolling and toxic. And due to those kind of things, a lot of people no longer want to be part of that community. And this is like game developers lose almost $1.6 billion a year due to this online toxicity and harassment on this gaming community. So this has a real life impact. Now, do we think that this type of toxicity or the harassment is only on the internet? This toxic culture is now spreading everywhere. So toxic culture has been shown in our workplace. So for example, this study that was done by Microsoft research inside Microsoft. Okay, and they say so that among many teams, software development teams at Microsoft, there is usage of toxic language. Okay. There was another study, recent study in Google, and they looked into code review practices, and they found that they found this phenomenon as destructive criticism. So destructive criticism is like somebody submits a code, you provide a very harsh critique, like demeaning that person. So you destroy their confidence. Yeah. A constructive criticism is like you provide suggestions to improvement, you provide encouragement. On the other hand, destructive criticism destroys this person's confidence, like you are nothing. So they saw that there is destructive criticism in Google. So these two research showed that actually this type of like our software development workplace, we think that software development workplace is a professional workplace. It's not like there are like more educated people in there. People are highly skilled, so it should be coming from this like online hate cultural kind of thing, but it's actually not. Definitely, software development workplace are less toxic, but still those things exist there. some of the examples we found from real open source projects. So you can see that in the first comment, okay, you can see that here, shame on you, shaming that person, the developer, for the code. Again, they don't need to provide this type of hash code. And this is another project. This is from Google Chromium. Google Chromium is sponsored by Google. Here you can see that it's stupid, and again here you can see that name calling is here. So this type of behavior also exists in software development, software development communication. Now, one of the things is the repercussion of toxicity is very severe. But these repercussions are even more severe for software development workplaces, especially open source. Yes. Think about, let's say, on Facebook, someone posts a harsh critique or someone does a name calling. What do I do? Okay, block it. Never communicate any other things and nothing else. Let's say I'm continuing to be open source, and somebody does something to me. What happens is I get frustrated. I no longer want to be part of this community. I stop contributing. Now, if this behavior continues, if enough people leave, productivity of this project goes down. Even if this project becomes too toxic, nobody wants to be part of that project. The project may die. Nobody is willing to maintain that. So not only in open source projects, even in industry, if there is this type of toxic culture and there is like harassment or like name calling going on, the productivity of teams gets dropped. So that's why toxicity and all this type of language has more severe impact on software development companies. So that's why it's urgent to mitigate those things. So that's what we have been trying to focus on, how to combat this type of behavior, how to combat this type of harassment or communication so that we can build more diverse and inclusive communication. Now, why I'm saying about diverse and inclusive communication? Remember, with this type of behavior, always research shows that disproportionately hurt minors. So in software development team, only 10% or 10 to 15% are women. So this type of behavior, women are more likely to face it. Or people, let's say, people who are LGBT, they are more likely to face harassment. So they are more likely to leave this community. So it hurts inclusivity, it hurts building a diverse software development community. So that's what said consequence of toxicity on software development or open source projects. It can cause burnout. It poses a barriers to promote diversity to inclusion. It obstructs newcomer onboarding, and it also sometimes even long-term developers no longer want to be part of this community anymore. Now, the investigation of toxicity and its repercussions seriously started around 2020, and this was from Raman and his colleagues at Carnegie Mellon, and they did a study to show that how toxicity in the community causes burnout or sales burnout or developers leaving the project. Another recent study by Miller and their colleagues, again from the Carnegie Mellon, in 2022, they show that like what the different type of toxicity behavior there, who the write these comments and what are the repercussions here. Another recent work in CSCW that show that, like, yes, toxicity is harmful, and those are more harmful for persons representing minorities, because they are more likely to get severely impacted by those things. So, and there is another one, this one study was done in Linux kernel. You know that Linux kernel is very genius, but it's also known for his brass communication style and his toxicity, and how this is affected those things another study here. So these studies show that yes, toxicity exists in software development community, and they have severe repercussions. So we need to have some mechanism to combat those. So that's why in the past phase, my students and we were looking into automated identification of toxicity. So why you want that? So think about an open source project. The open source projects like Chromium. Chromium projects every month has around 8,000 code reviews. So it amounts to actually it's like 300 code reviews per day. And think about how much communication goes on. So large scale projects have lots of communication collaboration going on between the developers. Now that means lot of these toxic interactions gets undetected unless someone complains to the authorities or maintainers and all these kind of things. Nobody gets any because automatically, manually detecting and going through these things. Again, a lot of the projects have this code of conduct. Okay, be respectful, do not use this type of language. But still, before this thing, nothing happens because there is no automated detection mechanism, there is no enforcement mechanism. So that's why what we are trying to do, can we build an automated identification? Okay, can we build a reliable automated detection? Now, one other thing I want to say that automated detection of tools for online toxicity is not a new concept in software. Because remember, this thing has been also going on in social media, blogs, internet, all over the place. So at least in general domain, people have been also trying to do that. Like people have been trying to identify toxicity on Twitter, toxicity on YouTube comments, blogs. People have been trying to do that. So one of the key one was perspective API. You can look into that. This is a API published by Google. You can use it. You can also use it for your site. You can send a text to this API. They will say that they will give a probability. Okay, is this toxic or what type of toxicity? You can use this one. The perspective API is one of the ones instead of the ordinary domain. And also to promote this kind of thing, to improve this area, Google Geekshotting with Kaggle, they created a competition. Competition in 2019, 2020, all this kind of thing to build better toxicity classifier. Okay. Now, yes, we have toxicity classifier, but the problem is software development domain has a distinct type of vocabulary. Many words has different meaning in software engineering domain. Okay. Now think about the word kill. Kill means killing someone. It is a very threatening word or something like that. But in software engineering, we always say that kill that process. Right? This is not part of our vocabulary. Then I'll look into many one like demo. demon, it has a different meaning of it. So we found a lot of words that in the general domain it has a one type of meaning, but in the software engineering domain it has a different type of meaning. So if we use a general domain specific classifier like perspective API, it will have lots of false positives. So that means these tools are not usable to identify toxic communication from software development. Okay. Then another also problem we found that software developers, I don't know, they sometimes use acronyms and all these kind of things that very confusing and all this kind of thing. So, do you know that, have you ever used GIMP, GIMP, GNU image manipulation? Okay. Do you know that GIMP has another meaning? Search dictionary and see what does the GIMP word mean. So, I don't know what the people are thinking about when they created this acronym. Okay. Then there was a namespace in Colloquium project, and I think that was like something like that. But the namespace, the name it WPF. Were they intentionally cloning? It did not know that this has a different meaning. So that means this creates also challenge, because this also creates lots of false positives. So that means, so we want to create a new toxicity classifier. But remember that in our software, to create this type of supervised learning classifier, first thing we need to do have a label data. Many of you use machine learning, and you know that our machine learning is a supervised learning classifier. We first have a label data set, we train the model. But that data set is missing. So that's the first problem we face. So, but to label a data set, we also need to think about what is toxicity. So think about the Google Jigsaw. Jigsaw team says that a conversation is toxic that when it makes the other person leave the conversation. Okay, that's when it is toxic. But this one is, I think, that like too liberal or too lax, because software development is professional workplace. So in a lot of the spaces, like some of the profanities, GAM, then oh my God, or something like what the hell, and all this critical language is not toxic in some places. But in software development workplace, we want professional conversation. Right? You should not use this type of language. So that's why we created a different, like we first define. So our team defined what should be considered toxicity in the software engineering domain. So we say that a software engineering conversation would be considered toxic if it considers it includes any of these things: so offensive name calling, insult, threats, personal attack, flirtation, obscenity, sexual expletives, swearing, cursing, all this kind of things. So we find that if it is considered any of those things, it will be considered toxic. So based on this definition, we actually created a rule book. For each of the rules, we had 9 rules. If it takes, and for each of the rules, we actually also created an example. And if a text follows any of those things, then we consider that it's toxic. And our definition, again, software engineering is a professional workplace, so our definition is more like strict. So, and then we look into, let's say this is our rubric for toxicity. We look into all these kind of things, self-deprecation. So another problem we also face there, like self-deprecation. It's called self-deprecation. It's also like when we look into the software data set, it's a problem. A lot of the people, when you say that, okay, you have done this wrong, they'll say, oh my God, I am dumb, I am stupid. This is called self-deprecation. And this is very common in software engineering. And but we cannot say that this is toxic. When you say you are dumb, then it's toxic. But when you say I am dumb, then it's not toxic. It is self-deprecation. So that's also another problem we also facing these days. So we created a rubric, and then, so this is our overview. So we downloaded code in the repository, and then this from like popular open source project, Android, LibreOffice, OpenStack, and Chromium. And then we did certify sampling because toxicity is not that frequent. So if we do random sampling, then our data set will be highly invalid. So what we did is we use a perspective API. So perspective API to level all this data set, and perspective API provides a probability if it is toxic or not. So then from each of the certified certification, so like probability 0.9 to 1, we take 1,000 samples. Probability 0.8 to 0.9, 1,000 samples. So for each of the start, we take 1,000 samples. And we also take a lot more 1,000 random samples. So we end up with like 19,000 samples, and then we label those things using 2 different authors, and we like resolve conflict through discussions. We measure iterator reliability. So we created the first large-scale data set of toxicity, and you can see that we have a very high iterator reliability. So that means the data set is high quality. We have 81% non-toxic sample and 90% toxic sample. So this data set has been used a lot recently by subsequent researchers in software engineering domain. So then using the data set, first we have to look into does general domain specific toxicity data work on the using the data set. And we found that the off-the-shelf existing tools, you can look that they are very good. They achieve very high F1 score and all this kind of thing. This is the general domain data. But when we use these tools on software engineering data set, code review data set, you can see that at most we get like 0.5 F1 score. And this is a binary classification. And for a binary classification, 0.5 F1 score is really bad. So that means we need to create a custom one. So then we actually created a tool, and we created a tool, a reusable tool to have algorithm selection, and also you know that the classifier performance depends on three processes. The software engineering data set has a lot of characteristics. It has the acronym, it has URL, it has code snippets. You need to think about all of these kind of things. Those keywords. So we also like have all these options, like you can see the discrete identifier, program keyword, count how many program words are there. So we look into all these kind of things. We implement all these type of features inside the boxes here, and then we evaluate. So to give you an example, how the pre-processing. The first thing, remember, software engineering data set will always include URL. Okay, URL do not express toxicity. So we need to remove the URL. So that's one pre-processing. Then you will have like a contraction. So you know that contraction is, we use contraction don't, but it actually do not, right? So don't and do not even say. So shouldn't or should not say. So we expanded this contraction so that those classical things that those are said. Then we will have symbols. So symbols can actually hard classify performance. So we use the symbol. Then people do a lot of different things. So for example, I know that loser. If I say loser, then classifier is detected. I will say hello loser. Or if I know that If I say the F word, classifier detective, it will say that F star CK or F underscore 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 CK. People do that. People do all these kinds of things to evade detection. So we need to find out this type of patterns. We need to see regular expression to find out that okay, this pattern actually means this type of toxicity. And also, those are pre-processing. You also have like keyword removal, again, programming language keyword will be always there. Identifiers, source code will be always there. So we need to remove those things. So we did all these type of pre-processing steps. And we actually also looked into, we also did an NPTEL study to find out, like, that is called embedding. Like when you want to read a text classifier, you need to convert a text into vector. And there are lots of different ways you can convert a text into vector. So fast text, globe, then there would be TF-IDF or bag of words model. So we actually looked into all this combination to find out which vectorizer works best for each of the algorithms. So we did that. Again, all of those things are details in the paper. And we also looked into that how this pre-processing step helps. Does it actually improve performance or not? So we also look into that. These are the impact of pre-processing steps are also the like algorithm dependent. Some algorithm gets improvement, some algorithm do not do that. So this is our like very brief summary of our classifier, and you can see that our classifier, the best performance we got from the part with keyword removal. You can see that we got 90% precision, around 88% recall, 88.9% F1 score, and 95.8% accuracy. So we actually build a toxicity, software engineering domain specific toxicity detector that is on par with like Google toxicity that we have for the general domain. Okay. So key contribution, we get a state of that AC domain specific toxicity detector and large level SSD dataset and ethical evaluation of algorithms and all these kind of things. And this paper is published in TOSEN. Our tools are actually publicly available on GitHub. A lot of the researchers are using the things. We already have 7 forks and this stuff on this side here. Now, after completing this research, we found that yes, binary classification is good, but binary classification has problems. So what is the problem? Some of the software engineering texts are very large. So let's look into this text. This text is very large, and our classifier says this is toxic. Now, why is toxic? To find out that I have to read the entire text, and sometimes some texts are very large. So you know that this one is toxic because of this one. Absolutely shitbag, right? But we have to read and look carefully to find out that. So that means we need a classifier, because remember, why are we building this tool? We will provide feedback to the project maintainer. Some text is toxic, but if text is very large and they have to go through a lot of time they will not use it. So we want something explainable. What is explainable? It's able to pinpoint the state. Why I am saying this text is toxic. Okay? So that means we will not, this is a different type of problem, like toxic quantification. So this problem, what we do, we had this our previous data set, and from the data set, what we do is all the 3,700 tags that we say that these are toxic. For each of the cases, we went through very carefully, and we have this labeling tool. We mark like individual 2 different data, mark that okay, this text is toxic because of this text is toxicity. So we mark the span, and there is a encoding for this type of task called IO encoding. So like which step. So what it does is it creates a vector, and for this vector, this specific part is the responsible for being toxic. It marks those part as 1, other part as 0. So it's basically from a text to the previous one. Remember, in binary classification, we present that, okay, we have this kind of problem. We have text, that is the input, output should be 1 or 0. For scan detection, we have a text as an input. A text should be a sequence of words, and output should be also a sequence of 1 and 0, where the words that are toxic that should be marked as 1. Okay, so that's the problem we are facing. So I'll not go through the details of this study. So we have this level studio we use for labeling. We have got a very good iterator reliability, and basically this works like this. This is a basically basic transformer model. So in classification transformer model, input is text, output is either 1 and 0. In this transformer model, input is text, output is a sequence of 1 0 1 0 1 0. Okay, so this is what we created, and this is what it does, and based on this you can see that it provides an output, and these are actually the output are basically a floating point number, that is a probability, and if the probability follows greater than more than that, then we convert it to 1 and 0, and then from that you can see that we say that from this one the output would come like this, and that means the second word is toxic. So we call this tool toxic scan, and this one we also use for a lot of different type of transformer models, and we also compared with the lexicon-based model. Because remember, toxicity often occurs due to profanity or all this kind of thing. So does it actually beat the basic lexicon-based model? Lexicon-based model or like a keyword-based model. So we also looked into that. And evaluation metrics, again, this evaluation metrics is a little bit different than our typical binary classifier. So it's a set theory-based approach. Like here we say that like the precision is like the set of the intersection between the predicted words and the ground truth. Ground truth is know that due to the labeling we say that it should be part of the toxic, and the predicted set. So if in the output we say our classifier said that these 3 words belong to toxic state, okay? And we look into what did our ground truth say, how many of this words. So we look into this set interaction, and based on that we create precision. And recall is similar like that. It's totally based on set theory. So we evaluated these results, and we found that our tool is very good. You can see that for toxic classes, it achieves 0.9 F1. Okay, so that means our tool is very good at doing that. And we also compared with lexicon-based approach. So you can see the lexicon-based approach it's not actually bad. It's 0.7, but we significantly outperform that one. Okay, so key contribution, explainable toxicity classifications of the software engineering domain, and we created this new transformer-based architecture to identify why software engineering is toxic. Okay, so once we look into the detection, okay, so once we completed the detection part, then we try to focus on empirical study part. Because to convince people that you should use this thing, you need to show them that. Why these things happen, how these things are harmful. So that's why we conducted a large scale empirical study on GitHub. So we this is how we work. Again, I'll go through very quickly. So we use the toxicity tool. Okay? And using this toxicity tool, we classify like almost 100 million toxic comments on this. Okay? Then we conducted a large scale test. So we look into the nature of toxicity, like what kind of toxicity are more frequent. We look into which projects are more toxic. We also look into why, like under which context toxicity is more likely to occur. And we also look into who are writing this comment or who are the targets. Okay. So here, what we do is we first identify, like using a search tool, we identify, we found that there are 89,000 projects that have at least 5 contributors and more than 20 contributors. We need to have some collaboration. From that, we created a stratified sampling strategy, like for each of the certification, we select like 800 projects, 800 small projects, 800 medium, 800 large, and also we have selected 400 gaming projects. So then we downloaded all the comments, so you can see that almost 100 million comments here. Then we use toxic here to find out all the toxic comments from there. And then we randomly selected 600 of those to find out that is the toxicity actually working well. And also we look into like what type of comments those are. Okay. And then we also did like a multiple multivariate mitigation models we change to find out project characteristics, context, and participants. Now, I will not go through all the results of all this kind of things. So I will just focus on key findings from it. So first we found that profanity. Profanity is the most dominant form of toxicity. So almost 58% in profanity. So we found that crap, then sheet, damn, all these kind of things. These are very common. This is like part of their vocabulary. And sometimes you wonder, like, I was saying that, okay, probably developers use those things so much that probably we should not consider them because they are part of the vocabulary. Then you can see that trolling, and it's also very common. So people troll a lot of it. Then insult. Insult we found very common, and certainly we found that a lot of the pieces, the insult and maternal insult. So what is maternal insult? They say that your mom or your grandma and all this kind of thing. Insult are related to others. Really unacceptable. Self-deprecation. We also find objective toxicity, like they do not like a tool, they do not think that this tool is hard, they do not like a compiler, they do not like a programming language, they rejected insult or profanity words. There are threats, arrogance, flirtation, obscenity, and all this kind of things, so we look into that. But what these are things that profanity is, profanity, trolling, these are the most common forms. So these studies keep finding. Okay, what we found? We found that profanity is the dominant form of toxicity. Surprisingly, trolling is common. We also found that gaming projects are significantly more toxic. The gaming communities are toxic. Often poor code. If you write a poor code, it's more likely that people will get annoyed. They'll have toxic comments. We also found that who write toxic comments. So we found that actually experienced developer write toxic comments. People will think that newcomers and all this kind of things are more toxic and all this. No, they have found that experienced developer write those things. We also found that there was a previous research. They said that women or newcomers will be more likely target of toxicity. But we did not find that in it. I found that actually women are newcomers, they do not like toxicity or they are not people. So toxic communication actually on behalf mostly happen between experiences. Okay? So that means there is a cultural issue. That's good. And toxicity for toxicity. That means people who write toxic comments, they are more likely to become this. Okay? So if you communicate with other people politely, people will also communicate with you. So this is a key thing. Like, be gentle, be polite. If you are polite, people will be also more likely to polite with you. Okay? Now, yeah, I'll finish within 5 minutes. Okay? So now I will talk about our ongoing work. Okay? So if you look into all our research, previous research, those are like post post interview. Somebody posted toxic comment, they can use Grammy classifier to find a toxic, inform someone, and then someone takes action or not, or all this kind of thing. So those tools are always trying to do that. And we think that maybe we should do some proactive. So someone tries to write, you know that proactive intervention is always there. There are already a lot of cases. Think about you are writing an email in Gmail. Have you tried recently Gmail or Office 365? Try writing something toxic, insulting, or something. They will actually provide suggestion. Recently, I have noticed in this last 3 or 4 months. So this is proactive. Sometimes you are sending email, Outlook will say that, okay, maybe you have forgot to attach something. So these are proactive intervention, right? So before something happens, you remind the people. And these proactive interventions are a lot more helpful because, yes, I can delete that comment or all this kind of thing. I have sent a comment and the person has already seen it. The harm is already done. So that means we need to be proactive before the text is sent. Now, proactive intervention is not that much easier. There are a lot of technical challenges here. So, what is our goal? So, our goal is think about this is a GitHub repository where you write a full repository. And you click on that button, you write, and realize that this code is entirely stupid. Okay? And before this text is posted on GitHub, we will notify the developer that, okay, it is toxic, you should not do that, perhaps you should write this. Okay? That's our goal. And we actually built a Google Chrome extension that we call this toxicity. And you can actually configure it for like which sites you want to enable it. And if you enable it, then from on that site or the text you write, it will monitor. So currently, I think we have only worked for full request reviews and issue comments on GitHub. Okay. So how did we do that? Remember, this type of model is called text style transfer model. Okay. This class is called text style transfer model in natural language processing. That means text style transfer model can be used in a lot of ways. Text is implied, transfer it to formal. A text is informal, make it formal. Okay. So, and many AI models, large language models also can do that. Many of you probably have used ChatGPT like that. Okay, this is the email. I'm trying to send, make it more formal. ChatGPT will refresh. So you can think about this is sort of like that. But this, remember, I already said that toxicity is different for software engineering. So that means general domain specific one will not work. So that's why we want to customize it because we want to make sure that knowledge is not lost. You are talking about some variable, talking about some function. If content is preserved, we preserve the style, we preserve the content, we do not change the meaning. So that's why we need a custom one. And for text style model, we need actually large scale. So fortunately, we have toxicity. And for our empirical study using toxicity, we level like 100 million tons. From this 100 million, we already have found like almost like 800,000 toxic. Right? So this is a really large data. So we actually does not use the 800,000 data. Saying 800,000 is very time consuming. So from that 800,000, we created a data set of 35,000. From the 35,000, we have 15, I think around 15,000 toxic scans and 22,000 non-toxic scans. Now, remember, in text style transform model, it has like the output is, this is the toxic one. Our input is toxic one, output should be same text replace non-toxic one. So it's a parallel data. So now creating this thing parallel data set, how we create it? Fortunately, we have GPT-4. So we fine-tune the GPT-4 prompt, and I say that this is a code review, this is going on, the author wrote this comment, do you think it's toxic, suggested, neutral, or polite, like reference. So we use that, and we also ask GPT-4 to explain, because we also need to explain why this is toxic. So we did that, we created this data set, and using this data set, remember, GPT-4 is good. It's the best one, probably. But this is very expensive. We cannot have real life data using GPT-4, right? And who will pay that cost? So that's why using the data set, then what we train open source LLM, the open source LLM like Claude and Llama 3.1, we fine-tune those things using the data set and try to find out if this data set can actually provide correct output, like explain why text is toxic and suggest a neutral alternative. So we found that like our best model decreases toxicity by 98%. So almost like only 2% is staying to provide an alternative solution that is not toxic. So this is how our implementation works. So this one, see, the code is entirely stupid. So when enter our browser-based plugin extension, how it works is if the text is not toxic, it will do nothing. Things will go normal. The comment will be posted on GitHub, everything will be there. But if text is non-toxic, sorry, if it's toxic, it will say that, well, this text is toxic, and why this is toxic, it will provide an explanation, and it will also provide that, okay, probably instead of writing this, we should write this. Okay? So that's how we implemented this tool. Currently, we are actually, remember, in software engineering domain, if you want to publish it to good places, you need to have a lot of different pieces. You need to do empirical evaluation, developer feedback, improvement. So actually, we are actually in that phase, like testing with real people, getting their improvement, and other suggestion, all this kind of thing. So that's what is our ongoing research is going on. Okay, so that's all. Thank you. And do you have any questions?